Hello all. We are starting one lecture session now on pressure measurement. We are here in the series of the lecture series on fluid mechanics and fluid and turbo machinery. So basically we have started our lecture sessions on basics of fluids, then properties of fluids. We had 3 lecture sessions on properties of fluids and 2 lecture sessions on the problems on the properties of fluids. So going further, basically in the particular point of the measurement of the fluids, the initial pressure is more important. So pressure measurement is a more important concept. So in this lecture, we are going to learn the various pressure measurement theories applied, what are the ways or how the pressure measurement is done, what are the laws which are governing the pressure measurement, etc. So hello all, my name is Savanwani. I'm assistant professor in Department of Mechanical Engineering in Padma Bhushan Vasantrao Dada Patil Institute of Technology, Budgaon. So I would like to request you, as already we are receiving a great response, so I would like to request you to just subscribe my YouTube channel for receiving more and more lecture session videos on the fluid mechanics and fluid turbo machinery. So we are going to start our lecture with the help of about the first slide, which is a pressure of a liquid. So how a particular pressure of a liquid is to be mentioned. But see that here, generally the first I would like to tell you a important thing here, that there are two types of values of P considered here. One will be a small p, will be the value of pressure, and second will be a capital P, which will be the pressure force. So just don't get confused in the values of or the actual notations which are given. Small p is related to pressure value and capital P is the pressure force. So whenever we have to find, see that the theory behind this is, whenever we are going to just flow a particular liquid from one point to another. Just take an example of a flow of a pipe. At inlet the water pressure is there, and at outlet also we are getting some pressure value. So if the area of the pipe is constant, then we can say that the pressure is remaining constant. But here now, for finding out some pressure of a particular value, it is dependent upon the force upon area. So basic definition of a pressure of a liquid we are going to see now. When the fluid is contained in a vessel, it exerts force at all points on the sides and bottom and top of the container. So see, the example is given to us that whenever a fluid is contained in a particular vessel or any constituent or object, then the pressure is acting in all directions. That is the first case. So basically this pressure which is acting, that we have to find. So the force per unit area is known as pressure. So if P is the force, that is the pressure force, and A is the area on which the force acts, then pressure can be regarded as or been calculated as the pressure force divided by area. So the pressure of a fluid on a surface will always act normal to the surface. This is the major thing here. Whenever we are going to find the value of a pressure of a liquid or a fluid on a surface, it will always be acting at the normal to the surface. Going to the next slide, how to calculate a pressure head of a liquid here. Now just see guys here that there is a vessel shown in this diagram, and there is a cylinder which is just dipped inside the particular vessel, and this vessel is completely filled with water. So for calculating this, the head is to be calculated inside the cylinder. So now if height is unknown to us, the height of the water available in the container is available to us. So we will see now how to calculate the value of head with respect to the pressure. So pressure head of a liquid. A liquid is subjected to pressure due to its own weight. This pressure increases as the depth of the liquid increases. Now this is a major thing, that if a liquid is subjected to pressure due to its own weight, then this pressure increases as the depth of the liquid increases. Means what? As the particular depth or the area of the liquid surface is increasing and increasing, as the height is increasing, naturally there is the pressure rise if the depth is increasing. Consider a vessel containing liquid as shown in the figure. The liquid will exert the pressure on all sides and bottom of the vessel. Now see that what will happen is, first consider that only a vessel is there and no any cylinder is placed inside it. So when the fluid will be there, it will be exerting the pressure on the vessel from all the sides, right, from the bottom side, the upward side, and all the sides of the vessel. Now let the cylinder be made to stand in the liquid as shown in the figure. Now what we have done is, we have just placed this cylinder inside the particular vessel. Let h is the height of the liquid in the cylinder. So keep this h, that is the height of the liquid in the cylinder. Capital A is the area of the cylinder base. Then W is the specific weight of the liquid, because other than water also there will be many types of liquids or fluids used. So W, specific weight of liquid, is also more important. And P will be the intensity of pressure. So now what we have to see, that there should be some equation which will be keeping this particular cylinder in the rest position in the vessel. So total pressure on the base of the cylinder will be equal to weight of liquid in the cylinder. So see, total pressure at the base of the cylinder will be equal to weight of the liquid in the cylinder, because if this is equal, then only the particular cylinder will be able to withstand the pressure inside the vessel. So that is, total pressure on the base of the cylinder will be pressure force into A. So therefore that is the force into area is equal to weight of the liquid in the cylinder, that is specific weight first, into area into height. This is the weight of the liquid in the cylinder. Then P we will keep this area here, so that area will be cancelled. So we get P is equal to WH. So that is P is equal to WH is the value for calculating the pressure head of a liquid. Then as P is equal to W, the intensity of pressure in a liquid due to its depth will vary directly with depth. Means what? It is only related with the height of the water or the depth of the water beneath this cylinder surface. So as the pressure at any point in a liquid depends upon the height of the free surface about that point, it is sometimes convenient to express a liquid pressure by the height of the free surface which would cause the pressure. So again we will see this sentence. As the pressure at any point in a liquid depends on height of the free surface above that point. Means what? Suppose we have to take the pressure at this upper point, then it depends upon the height of the free surface about that point. Means what? How much depth the water is there in the particular vessel or the cylinder. It will define the amount of pressure. It is sometimes convenient to express a liquid pressure by the height of the free surface. So this H height is more important. If this vessel would have been halfly filled, then the amount of pressure exerted by the liquid surface on the cylinder would have been different. So we are taking that as P was equal to WH. So now H will be equal to P by W. The height of the free surface above any point is known as a static head at that point. See, height of the free surface about any point means this height which is given to us, it is known as a static head at that point. In this case, static head is H, that is this value, which is the over the particular actual surface of the water. Hence, the intensity of pressure of a liquid may be expressed in two ways. First will be either it is force per unit area, so it is Newton per mm square or Newton per meter square, or as an equivalent static head, that is meters, mm, centimeter, etc. So in this point we are directly concluding that either we can measure the pressure in terms of pressure intensity, or we can measure the pressure exerted with the help of this static head, that is the height. Then now the basic thing which we have to learn is the Pascal's law. So first we will see the diagram, and then we will go for the statement of the Pascal's law, and also we will see the equation of the Pascal's law. Now what does Pascal's law states us that? First we have taken a right angle triangle based on the angle of LMN. It is having an angle of LMN. So on the face LN, the horizontal force which is acting is Px. On the face Mn, the vertical force which is acting is Py, and all the on the surface, that is, or the on the face Lm, the perpendicular force acting to this Lm is Pz. So all are having their own directions of pressure is Px, Py and Pz, and this right angle triangle is having LNM is a right angle triangle, but LMN is an acute angle, so it is given the angle as alpha. So what does this say? This Pascal's law states us that the intensity of pressure at any point in a liquid at rest is the same in all directions. Means what? Suppose if we are taking any element here inside this, so the intensity of pressure which is at rest of a fluid, it is same in all directions. Means the pressure acting on that particular fluid point or the liquid point is similar in all directions. So let us consider a small wedge shaped element as we have seen, LMN. Px is the intensity of horizontal pressure on the element of liquid, then Py is the intensity of vertical pressure on element of liquid, and Pz is the intensity of pressure on the diagonal of the right angle triangle element. As we have seen, this Px horizontal, Py is vertical, and Pz is the diagonal force. Angle that is alpha is the angle of the element of the liquid. This element we have taken into consideration. So Px, Py and Pz, that these are the actual total pressure values. So total pressure on vertical side will be capital Px, capital Py will be total pressure on the horizontal side, that is Mn, and Pz will be the total pressure on the diagonal side, that is Lm for the liquid. Now for calculating Px, that is the total pressure. Now again, as I told you that don't get mixed up in these two values. This capital Px is total pressure and this small px is the intensity of pressure at that particular point. Then Px, capital Px is equal to small px into ln. Call this as equation number 1. Capital Py will be equal to small py into mn. Call this as equation number 2. Pz, that is capital Pz, equal to Pz into Lm. So call this as equation number 3. Now see, as the element of the liquid is at rest, therefore the sum of horizontal and vertical components of the liquid pressures must be equal to 0. Now see, as we have considered that this fluid element is at rest, so therefore the sum of all the forces should be equal to 0. Resolving the forces horizontally. Now how to resolve these forces? Just see, this is Pz, so it is a diagonal force, so we have to resolve this in either in vertical direction first and second in the horizontal direction. So when we are going to resolve this in horizontal direction, it will go in the right hand side, and in the vertical direction it will go in the downward side. So when we actually resolve the force horizontally, then we will get it as Pz sine theta, that is sine alpha, is equal to Px. We are going to find in horizontal way like this, that for example, there are only two horizontal forces here, that is this Pz and this Px. So what we have done is either writing it as minus and equal to 0. The first equation will be like this, that positive because it is going in right hand direction, so Pz sine alpha, and Px is going in left hand side, so it should have been minus Px is equal to 0. So this minus Px will come in right hand side, and therefore we will get this equation, that is Pz sine alpha is equal to Px. Then just actually writing the values, Pz as per the equation number 3, we are having small pz into Lm, and this capital Px is small px into Ln. So therefore the values are just been put like this, Pz into Lm sine alpha is equal to Px into Ln. Now see, but what is Lm here? This Lm phase is equal to, directly this Ln will be calculated as Lm sine alpha. So if we keep it like this, Lm sine alpha, then from equation number 1, 2, 3, we get this fourth equation as Pz equal to Px. So actually this intensity of pressure at Px is equal to Pz we have proved. Now resolving the forces vertically. Now see, vertical force is the actual weight of the element, that is W. Pz cos alpha, because it is the vertical direction, is equal to Py, that is this vertical, that is again positive direction force, minus W, the weight is going in the downward direction. So since the element is very small, we are neglecting its weight, so weight is neglected here. So here we get this Pz cos alpha is equal to Py minus W. So this Pz will be Pz cos alpha is equal to Py or Pz. Lm cos alpha is equal to Py Mn. So directly we get here as Lm cos alpha is equal to Mn. So we get it as Pz is equal to Py. So if we write this value, then from 4th and 5th equation, as Px is equal to Pz and Py is equal to Pz, we get it as Px is equal to Py is equal to Pz. So we have proved here that in Pascal's law that the intensity of pressure in all directions on a fluid surface or a fluid liquid point which is at rest is same in all directions. So here they are independent of alpha. Hence at any point in a fluid at rest, the intensity of pressure is exerted equally in all directions, and which is called as Pascal's law. Now going for the various types of pressures, this is a very easy point. You must have learned this in the science problems also, or whenever you are in schools or in 11th 12th sciences also, but we are going to repeat this as it is a part and parcel of the pressure measurement. Absolute and gauge pressure. So the first type of pressure is atmospheric pressure. So the atmospheric pressure exerts a normal pressure upon all surfaces with which it is in contact, and it is known as atmospheric pressure. The atmospheric pressure is also known as barometric pressure. The atmospheric pressure at sea level is called as standard atmospheric pressure. So here no need of any, I think, of the explanation that the atmospheric pressure is there, which acts on all the surfaces when it is not at all actually confined in a particular space or etc. Now next type of pressure is gauge pressure. It is the pressure measured with the help of pressure measuring instrument, in which the atmospheric pressure is taken as the datum. What is the datum here? Datum means a standard reference value. So here atmospheric pressure is taken as standard reference value. So the pressure above atmospheric is also, remember, it is always a gauge pressure. Okay, I will repeat again. Pressure above atmospheric pressure is always a gauge pressure. The atmospheric pressure on the scale is marked as 0. Now gauges record pressure above or below the local atmospheric pressure, since they measure the difference in pressure of the liquid to which they are connected and that of surrounding air. So these are the gauges which are used to measure the pressure. They create some difference between the fluid and the surrounding air. If the pressure of liquid is below the local atmospheric pressure, then the gauge is designated as vacuum gauge. So again, see, another type of gauge here is there, or we can say another type of pressure. So gauge pressure will be there and vacuum pressure will be there. So again, see, I will repeat this value. Atmospheric pressure will be the standard pressure. The pressure above atmospheric will be the gauge pressure, and the pressure below atmospheric will be the vacuum gauge pressure. And the recorded values indicates the amount by which the pressure or the liquid is below local atmospheric pressure. So vacuum pressure is defined as the pressure below the atmospheric pressure. As we have explained, the pressure below atmospheric is vacuum. So it will not have the negative value. It will have some negative value, but it will be regarded as a vacuum pressure. Then next, this is the major system when we are going to see the measurement of pressure. These actual lines are more important. So see, this line is showing on the y-axis we are having pressure, and here there is a 0 absolute pressure. So now you can see that this blue line, which is the atmospheric pressure, and so this atmospheric pressure over atmospheric or above atmospheric is positive gauge pressure. Below atmospheric is negative gauge pressure or vacuum pressure. So now this is clear, I think, to all of you, that atmospheric pressure is standard, above atmospheric is gauge, and below atmospheric is vacuum. Now for measuring the absolute pressures, there are two formulas used. Is that first is, you can write this absolute pressure. Now see, there are two lines. This is the first absolute pressure and this is the second absolute pressure, but these both will be dependent on the standard values of the atmospheric pressure. So see, you can write this formula with the help of atmospheric pressure. For calculating this absolute pressure, I can write that atmospheric pressure plus gauge pressure is absolute pressure. This much is atmospheric and this much is the gauge pressure. Or second formula I can write here is atmospheric pressure minus vacuum pressure is this absolute pressure. So is it clear now that this is the absolute pressure, and this is the another type of absolute pressure. One is atmospheric plus gauge, and second is atmospheric minus vacuum. So it is necessary to establish an absolute pressure scale which is independent of the changes in atmospheric pressure. A pressure of absolute zero can exist only in complete volume. So absolute zero pressure will only exist in the absolute zero pressure region. Mathematically, absolute pressure will be equal to atmospheric pressure plus gauge pressure, that is P absolute is equal to P atmospheric plus P gauge, or the vacuum pressure will be equal to atmospheric pressure minus absolute pressure. So we can find it in two ways. The final point is unit of pressure. Fundamental unit of pressure is Newton per meter square, as it is force per unit area. So force is in Newton and area is in meter square. So there are many types of units for particular value of pressures, like Newton per mm square, then 1 bar, then Pascal, etc. So this Newton per meter square value is also known as a Pascal. So 1 Pascal will be equal to 1 Newton per meter square. Low pressures are often expressed in terms of mm of water or mm of mercury. So if the low pressure values are there, they are measured in mm of water or mm of mercury, and therefore these type of low pressures are measured in the various types of low pressure measurement instruments, like manometers or pitot tubes or piezometric tubes. The low amount of pressures are measured. If we want to measure the high amount of pressures, then we can use bourdon tube pressure gauge, then a bellow tube pressure gauge or diaphragm pressure gauges are used for the measurement. So guys, this is something about the pressure measurement. Hope you are enjoying our lecture sessions on fluid mechanics and fluid and turbo machinery. Still we have to go very deep in fluid mechanics, so we are not just now taking the consideration of fluid and turbo machinery, but we have given a particular name to our lecture series as a fluid mechanics and fluid and turbo machinery. So hope you all are enjoying. Please kindly subscribe our YouTube channel for receiving more and more videos. Thank you.